How electric locomotives, electric trains work. What is an electric locomotive? An electric locomotive is a railway vehicle that can move along rails and push or pull a train as attached to it using electric power drawn from an external source, usually from overhead cables or a third rail. Electric locomotives do not have a conventional engine in them as we have seen in a diesel locomotive, but use the electricity collected from the outside source to power traction motors which turn the wheels. Types of electric locomotives. Electric locomotives are of three types: those which can work on DC direct current, AC alternating current, or on both AC or DC by current. Electric locomotives throws highs on electrical and engineering work on the single principle of drawing current from external sources and then after sufficiently modifying it feed it to the traction motors. The process of modifying the raw current drawn from outside into uses power includes a complicated process of conversion, reconversion, smoothing, and transformation of the current to varying values of frequency, voltage, current, etc. Construction of AC electric locomotive. This involves a bank of many components like transformers, rectifiers, inverters, capacitors, thyristors, compressor, and other such paraphernalia housed within the locomotive body or the shell, and there is no central engine or primer mover. All of this has to be done for optimum performance of the traction motors under different conditions and loads. By current locomotives work according to the same principles, only they have more equipment packed inside them to enable them to work under both type of currents. Each one the pantographs are used to collect a specific type of current only. Modern electric locomotive block diagram. Power circuit in AC electric locomotive. The electric locomotive draws power from the overhead equipment OSC with the help of pantograph and converts this electrical energy to mechanical energy in controlled manner through traction motors which drive the axles to enable to the locomotive to perform this task. It is equipped with suitable equipment which enable loco-pilot to control the speed of the train as per requirement by controlling the applied voltage to traction motors. In conventional locomotives, 25 kV single phase AC supply is collected by a roof-mounted front pantograph from the OSC and is stepped down by a transformer inside the locomotive. This supply is then converted to DC supply by a full wave silicon rectifier and associated smoothing filter before being fed to the traction motors. Torque speed control is achieved by variation of the AC input voltage to the rectifier throws and all on-load tap changing arrangement on the primary winding of the loco transformer. The equipment on electric locomotive depending upon where it is located can be classified in their different categories is number 1 roof equipment, number 2 inside equipment, and number 3 under frame equipment. Both the roof and the under frame equipments are subjected to lot of dust and atmospheric pollution and are therefore designed to withstand this severe work condition. Number 1 roof equipment pantograph. The high tension current 25 kilovolt for feeding locomotive is taken from contact wire by means of current collecting device called pantograph. Each loco is provided with two similar pantographs on the roof. As a practice, The rear pantograph is generally used as circuit breaker, air burst, a circuit breaker, vacuum circuit breaker. When the circuit breaker closed manually through remote control, OAC supply collected by pantograph is made available to the main transformer inside the locomotive. Inside equipment voltage regulating equipment, the highest OSC voltage is stepped down to low voltage by the main transformer compression of an auto transformer with 32 steps and a stepped down transformer with two separate secondary windings. The low voltage can be controlled from 0 to maximum throws on low tap changer, which can be compared with a fan regulator used to control the fan speed. Silicon rectifiers. Since the traction motors are AC motors, alternating current supplied by secondary windings of main transformer is converted into direct current by means of two silicon rectifiers. RSI 1 is feeding to set of three traction motors. Arno converter converts the single phase 380 volt input from transformer auxiliary winding to three phase 380 volt output. The three phase output of Arno converter is supplied to various auxiliary motors provided from supplying compressed air, creating a vacuum in train and cooling of electrical equipment such as traction motors, smoothing reactor, rectifier block, main transformer, etc. And number 3, under frame equipment, traction motors. In general, the locomotive is provided with 6 DC series type traction motors TMS. These TMS are mounted in two under frame bogies coupled with wheels, throws, pinion gear arrangement, smoothing reactor as output of rectifier of is of undulating pulsating nature. It is passed through an inductive choke called smoothing reactor essential to reduce undulation of the current and to make current smoother. Number 4, brakes. Loco is provided with following brakes: air brake system, independent brake, proportional head brake, dynamic brake, regenerating brake. Working of DC electric locomotive. In DC locomotives, the speed of DC traction motors is controlled by connecting all the traction motors in series during a starting period and introducing a starting resistance. These starting resistance are gradually cut out from the circuit and the voltage across the traction motors gradually increased. This is further followed by changing motor combinations from series to series, parallel, and finally all the motors are connected in parallel so that loco can haul the train at its maximum permissible speed. Working of three-phase locomotive. 25 kilowatt overhead AC supply is stepped down with the main transformer in the locomotive and fed to a front end line 24 quadrant line converted where AC is converted to DC through pulse width modulation PWM, thus achieve unity power factor. This supply is linked with an input side converter through DC link, which is a reservoir of energy. Drive converter converts a DC supply into three phase, which is then fed to three phase traction motors. Get turn off GTO thyristors are used in converter or inverter. The output of drive converter inverter is variable voltage, variable frequency supply, which helps in controlling the starting and running torques of three-phase traction motors to suit traffic requirements.